Neil deGrasse Tyson on the Webb telescope and the Big Bang. You probably already know this, but did you realize that Neil deGrasse Tyson's explanations of the James Webb Space Telescope and the Big Bang will make you rethink the fundamental nature of the universe itself? Should we reevaluate the Big Bang theory? Popular researcher and scientific communicator Neil deGrasse Tyson has spoken openly about the significance of the James Webb Space Telescope, or JWST, and its central goal to more readily figure out the universe. Tyson has said that the JWST will revolutionize astronomy in several interviews and public appearances. Tyson claims that the JWST will be the most powerful telescope in space. Its primary purpose is to conduct groundbreaking astronomical research, especially in the infrared region of the electromagnetic spectrum. The telescope will use its cutting-edge technology and sensitive instruments to investigate questions like how galaxies develop, how stars are born, and whether or not exoplanets exist. Tyson emphasizes the JWST's ability to look far back in time and space, providing scientists with a window into the cosmos' infancy and answering fundamental questions about the universe's origins. He talks about how the telescope can help us learn more about the cosmos and encourage the next generation of scientists to make significant discoveries. The telescope's principal goal is to increase our cosmic knowledge. The telescope has several uses beyond making groundbreaking observations and discovering new cosmic phenomena. Telescopes let us see distant galaxies, star creation, and death. Their genuine value is in their wisdom, information, and understanding. Telescopes help us understand gravity, the expansion of the universe, dark matter, and dark energy through diligent observation and inquiry. These initial principles can increase our understanding of the cosmos and its underlying mechanisms. Our comprehension of the cosmos is going to undergo a sea change as a result of the James Webb Space Telescope, or JWST, which is more commonly referred to as the Webb telescope. This telescope is going to build on our existing knowledge and expand our comprehension of a variety of phenomena. Insights into the universe that have never been seen before will be made available by the James Webb telescope thanks to its cutting-edge capabilities and cutting-edge technologies. The development of galaxies and stars is one of the most important topics that the James Webb Telescope aims to investigate. We shall be able to solve the mysteries of how galaxies came to exist and how stars are produced if we look at the very first stages of the growth of the universe. This can be done by examining the very early phases of the universe's development. The telescope will make it possible for researchers to analyze the chemical makeup and atmospheres of exoplanets, which might lead to the discovery of indicators of habitability or perhaps life beyond Earth. The Webb telescope's infrared capabilities will allow it to see through cosmic dust clouds, unveiling hidden astronomical objects and shedding light on the process of star birth and death. In addition to this, our understanding of planetary system formation, black holes, and dark matter will be expanded as a result of this discovery. The discovery of exoplanets has greatly advanced humanity's understanding of the cosmos and its limits. This area of research has great promise for discovering many more exoplanets and expanding our understanding of the cosmos. Scientists have discovered exoplanets, planets that orbit stars other than our Sun, using cutting-edge observational methods and technologies. Each exoplanet discovery illuminates the cosmos' vast planetary diversity. Scientists learn more about life's conditions as they uncover more exoplanets, understanding planets' atmospheres, compositions, and habitable zones. These discoveries help answer the age-old question of whether humans are alone in the universe. Tyson has distinct memories of being on national television to talk about the discovery of the first exoplanet. He had hoped for years that the existence of planets beyond our solar system would be confirmed in his role as an astronomer and scientific broadcaster. It was a time of immense significance to be able to announce this groundbreaking news on such a prominent stage. Tyson felt both the weight of responsibility and the majesty of the occasion when the camera started rolling and millions of viewers tuned in. He spoke eloquently about the discovery, including the procedures that were utilized and the implications it carried for our view of the cosmos. He harped on the enticing prospect of life on other planets and the existence of potentially livable worlds. The public's reaction was phenomenal. The concept that our cosmic neighborhood is much larger than we had previously believed attracted people all around the country. The news reignited people's interest in space travel, and it motivated many young people to study science or become astronomers. Everything considered, discussing the revelation of the first exoplanet on public TV was a turning point for Tyson's profession and the comprehension of the public might interpret the universe. There is a persistent development and advancement of human comprehension because of logical advancement, which is a unique cycle where new understandings are retained into current information. It is a collaboration wherein researchers, scholastics, and inquisitive personalities from one side of the planet to the other work together to develop the discoveries of the individuals who preceded them. The first step in making observations and coming up with theories about what might be causing the phenomenon being studied. Scientists put these ideas to the test through extensive experimentation and data collection in an effort to prove or disprove them. The data gathered from these tests is subsequently examined and interpreted. When new information becomes available, it is not treated as a separate entity, but rather incorporated into the overall body of knowledge. Researchers examine the significance of the findings, compare them to current hypotheses, and determine whether or not they warrant additional investigation. In order to achieve this synthesis, it may be necessary to revise or even abandon some previously held theoretical beliefs. The cumulative nature of knowledge is essential to scientific progress, as each new discovery expands our understanding of the world around us. Through this iterative process, scientific knowledge is constantly refined and improved, paving the way for new discoveries, paradigm changes, and the advancement of society as a whole through technological innovation. Understanding of the physical cosmos has progressed over time, as evidenced by Tyson's recognition of the limitations of Newton's equations of motion and gravity, and the subsequent breakthroughs brought about by Einstein's theory of general relativity. The amazing foundation for explaining the motion of things and the force of gravity was created by Newton in the 17th century in his three laws. However, as research continued, it became clear that Newton's laws did not provide a complete explanation for certain phenomena, such as the deflection of light near big celestial bodies, or the behavior of objects in extremely strong gravitational fields. In the early 20th century, Einstein's theory of general relativity introduced the concept of space-time curvature, which fundamentally altered our understanding of gravity. Warping of space-time due to heavy objects is the source of gravity, according to general relativity. This framework not only explained observed phenomena like the precession of Mercury's orbit and gravitational lensing, but it also compensated for the constraints of Newton's theories. The repetitive nature of scientific progress, in which new theories build upon and enhance earlier ones, is brought into focus by Tyson's discussion of these developments. Scientific data supports the Big Bang theory, a popular universe genesis theory. It argues that the universe began as a singularity, an infinitely small and dense point, which rapidly expanded to form the huge cosmos we see today. Scientists are always researching the universe's mysteries and alternate ideas. These include the potential of a multiverse. The Big Bang theory explains the growth of our observable world, but conjecture about alternative universes continues. A multiverse implies many universes with their own physical laws. To explain the cosmos and its extensions, scientists are studying string theory and inflationary cosmology. They seek to discover more about the multiverse by investigating cosmic microwave background radiation, galaxy clustering, and other cosmological events. A multiverse is an intriguing hypothesis that expands our understanding of the cosmos. It proposes that the Big Bang, the beginning of our universe, is one of many events in a vast and linked cosmic landscape. This theory states that our universe is a bubble in a huge space, with each bubble representing a new universe with its own physical rules and attributes. These universes may have originated from independent Big Bangs or other unknown processes. The multiverse concept challenges our beliefs in a single, self-contained universe and questions reality. It allows alternative dimensions, alternate histories, and other realities. The multiverse idea encourages scientific inquiry and philosophical reflection on the cosmos' majesty and intricacy. Astrophysicist Tyson stresses the importance of testing and proving hypotheses when exploring parallel universes with different mechanics. Understanding the laws of our universe is simply the beginning of considering other universes with other physical laws. Tyson promotes scientific inquiry because it underpins knowledge. He emphasizes the importance of careful experimentation and observation to test theories and draw empirical findings. Scientists entering parallel universes must be cautious since their fundamental laws may not apply. To explain phenomena that contradict their assumptions, they must change their methodologies and frameworks. They can understand these foreign domains and realities by rigorously verifying their hypotheses. Tyson believes that exploring multiple universes is a fantastic opportunity to learn more about the cosmos and ourselves, but we can only do it with confidence if we test and verify. If you found this video helpful, please hit that like button and subscribe to our channel.